You know, I was at a repair shop the other day and I saw this mechanic just pressing a small lever, and this entire car, easily weighing over a ton, was smoothly lowering down. And then there's this press machine cutting through solid metal parts like butter, or take these massive industrial plants producing seamless steel pipes, handling forces that could crush almost anything. So here's the question: what actually powers all this massive force? Whether it's a mechanic's garage or a steel plant, that's exactly what we're going to explore today. And by the end of this video, we will find what is this machine, its components, its wide range of application, and finally, we will calculate the required size based on working real life application. So this is a hydraulic power pack. You might have seen these in factories, workshops, or even in equipment around you without realizing it. Basically, it's the heart of any hydraulic system. Think of it like this: if hydraulic cylinders are the muscles doing the work, the power pack is the heart pumping the energy to make everything move. And honestly, from my experience, understanding how to size these correctly can save you from so many headaches down the line. Now, let's break down what's actually inside this unit, right? So, every hydraulic power pack has a few essential components. You've got your electric motor, that's what drives everything. Then there's the pump, which is actually converting that mechanical energy into hydraulic pressure. You'll see valves for controlling the flow and direction, filters to keep the oil clean, which is super important actually, and sometimes an accumulator for storing energy and smoothing out pressure spikes. Now, in some industries, especially where there's continuous operation or high ambient temperatures, you'll also need an oil cooler. See this unit here? It has an integrated oil cooler. Basically, it prevents the hydraulic oil from overheating, which can damage seals and reduce efficiency. Alright, so hydraulic power packs come in different types depending on your application needs. You've got your standard power packs. These are the most common ones you'll find in factories. Then there are compact units, perfect when space is limited, like in mobile equipment. Servo power packs are for applications needing precise control, very smooth operation. And finally, if you don't have electric power available, you can use air driven, gas driven, or diesel petrol driven units. These are quite handy for remote locations or mobile applications actually. Now, here's where it gets interesting. Let me show you where these power packs are actually being used. Look at this, a medical operating table. The doctors can adjust the height, tilt the angle, and position it exactly as needed, all powered by a compact hydraulic power pack underneath. Smooth, precise, and completely reliable. Or take the food industry. This is dough preparation equipment, handling hundreds of kilos of material, mixing it uniformly. Again, hydraulic power pack doing the heavy lifting. Here's a cotton ginning machine using a standard hydraulic power pack. And this is roll forming machinery, also running on hydraulics. Both these applications need consistent high force, right? That's where these units excel. Paper production plants. These handle continuous operations. So you need a reliable standard power pack that can run for hours without issues. Now, this one's pretty common. Hydraulic car trailers. Compact power pack makes it easy to load and unload vehicles. You see these everywhere actually. Briquette production equipment. Notice this one has an oil cooler because of the continuous operation and heat generation, and press stamping machinery. These applications need high force at precise moments. Now, there are honestly so many more applications. I've just scratched the surface here. If you want to explore more examples, I've put together a detailed list on our website. You can scan the QR code on screen or just check the link in the description. Go to the Hydraulic Powerpack section and you'll find an application section there. And actually, one of my favorite applications shown there is a roller coaster ride in an amusement park, powered by a massive hydraulic unit. Pretty cool, right? Alright, now let's get into the main part. How do you actually calculate and size a hydraulic power pack? This is where most people get confused. But I'm going to walk you through a practical example that will make it clear. So, imagine this setup. You have an index cylinder that pushes a part forward 150 millimeters, positioning it exactly below a press cylinder. Then the press cylinder moves down 400 millimeters in 4 seconds. This is the approach phase, right? Not much force needed yet. After that, it moves the final 50 millimeters in 6 seconds, but with much higher force because now it's actually pressing the part. Once pressing is done, the cylinder retracts back up 450 millimeters in 4 seconds. And finally, the index cylinder pulls the part back out 150 millimeters in 3 seconds. So basically, you have 4 functions happening in sequence, and each function has different force, speed, and distance requirements. Now, here's how we calculate it. First, for each function, like index forward, press in, press out, index reverse, we need to enter some data. Things like the moving mass, acceleration, cylinder bore, and rod diameter, quantity of cylinders, and which side is pressurized, bore side or rod side. Why do we need all this? Because from this data, we can calculate the effective area of the cylinder, and the moving mass plus acceleration helps us figure out friction forces and inertia forces actually. Then, for each function, you enter the required force, the distance it needs to travel, and how long it should take. Notice here, we've entered press in twice. Why? Because first, the cylinder moves 400 millimeters with less force, and then 50 millimeters with much higher pressing force. Two different requirements, right? Once you enter all this data, you get the required pressure and flow rate for each function, and from that we can determine the hydraulic horsepower needed. I'm intentionally keeping this high level here because the full calculation is quite detailed, and that's exactly why I built the calculator in the first place. It handles all the complex math so you don't have to. Now, from all the functions, we pick the maximum hydraulic power required. Basically, whichever function needs the most power. Based on that, we calculate the electric motor power needed. Usually, You add some safety factor here actually. Then, from the flow rates of all functions, we find the maximum flow rate. From that, we determine the pump displacement, which basically tells you what size pump you need. And finally, the tank size. Generally, we take the tank capacity as 3 to 5 times the flow rate, but it can vary depending on your application. In some cases, the tank can be as small as half the maximum flow rate. This depends on factors like duty cycle, heat generation, and how much reserve you need. So there you have it. From understanding what a hydraulic power pack is, to seeing real world applications, to actually calculating the specifications you need. From my experience working with hydraulic systems, getting these calculations right from the start saves so much time, money, and prevents equipment failure down the line. Now, we've covered the basic calculation here, but what if your application needs an oil cooler or an accumulator? How do you size those? That's coming in the next video, so stay tuned for that. And actually, if you want to make these calculations much faster and more accurate, I've developed a calculator specifically for this. It handles all the complex formulas in the background, and you just input your requirements. Check the link in the description if you're interested. It'll save you hours of manual calculation, honestly. Alright, if you found this helpful, hit that like button, subscribe for more engineering content like this, and drop any questions in the comments. I read all of them and I'll help you out. Thanks for watching, and I'll see you in the next one.